Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to make a tax-deductible donation to support our students, please go to smarturl.it/help-ISU-actuary. And here's a problem for today. A father-son club has 4,000 members, 2,000 of which are age 20 and the other 2,000 are age 45. In 25 years, the members of the club intend to hold a reunion. You are given that all lives have independent future lifetimes. Mortality follows the standard ultimate life table. That's the table on exam LTAM. And of course, this is a practice problem for exam LTAM that is given on this new exam. Please remember, that's a very important thing to remember, that the exam LTAM uses a new, different table than exam MLC. This is a problem, one of the problems that Society of Actuaries published, where the problem is very similar to a past exam problem, fall 2015 exam MLC problem in multiple choice section problem number 1, but it tells you to use the new table, standard ultimate life table, while the old problem from fall 2015 was using the illustrative life table used on exam MLC. So there's a substantial change in the table, and you need to get used to the new table and make sure that you look it up. Okay, and where do you think you can find a standard ultimate life table? Well, Society of Actuaries gives you that information at their website, but hey, you know where you can find it. It's called SULT. So it is at smarturl.it/SULT. Obviously, I have created that smart URL for you so that your life will be easier. Using the normal approximation without the continuity correction, calculate the 99th percentile of the number of surviving members at the time of the reunion. And here's the solution. For the survival of every member of the club till the reunion is a Bernoulli trial. The person either survives or doesn't survive. And we will find the mean and variance of the number of surviving members at the time of the reunion from what we know about the mean and variance of a Bernoulli trial. Or specifically that Bernoulli trial, but it's different for sons and fathers, and anyway, we'll go over it. But we just need to note that this is a Bernoulli trial for each person. From the standard ultimate life table, we get 25p20 to be L45 over L20. We look those two up in the table. We get these numbers that you see there, and that's about 0.990339. And 25p45, the probability of survival. So the first one is the probability of survival for sons, and the other one is the probability of survival for fathers. And that's L70 over L45, and that's approximately 0.919709312. The expected number of survivors from the 20-year-old sons is 2,000 times that 25p20, and comes out to be about 1,980.678. And the variance of the random number of survivors from the 20-year-old sons is, the mean times 1 minus the probability of survival, so that comes out to be about 19.13533. The expected number of survivors from the 45-year-old fathers is 2,000 times the probability of survival, which we just calculated, and that comes out to be about 1,839.418623. And the variance is that multiplied by 1 times the probability of survival, and that's about 147.6881874. And the total number of survivors, expected number, is the sum of the two expected values. So that's 3820.0966. And because individual lifetimes are independent, the total variance of the random number of survivors is the sum of the two variances, because we can add variances for independent random variables. So that comes out to be about 166.82352, and the square root of that is the standard deviation. That comes out to be about 12.916018. The random number of survivors in a sum of 2,000 independent, identically distributed random variables. The random number of survivors is a sum of 2,000 independent, identically distributed random variables, and the sum of independent, identically distributed random variables is approximately normal for a large number of random variables added. 2,000 is quite a lot. So it can be approximated by a normal variable because of the central limit theorem. Similarly, the random number of father survivors is a sum of 2,000 independent, identically distributed random variables, so it can be approximated by a normal variable. Because these two variables are independent, their sum can also be approximated by a normal variable with the same mean and variance as that sum. And then we are ignoring continuity correction in what follows, in what we're doing here, because it really doesn't matter anyway. Since the 99th percentile of the standard distribution is standard normal distribution, sorry, I should say that, is 2.33, the 99th percentile of the number of surviving members at the time of the reunion is approximated as 3820.0966, the mean, plus 2.33, the quantile that we're interested in, plus the standard deviation of 12.916018, and that comes out to be about 3850.190945, or 3850 approximately, which is answer E. Please remember this is copyrighted material. The problem itself comes from the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.